All right, in example 2b, we have our same two original functions. F of x is equal to 3 over x minus 1 and g of x is equal to 2 over x. This time we're forming g of f. Okay, so as soon as you see the open circle, that means composition. So we're going to rewrite this as g of f of x so that you can see that we're plugging f into g here. Okay, so I'll write this out to the side. F is our inside function. G is our outside function. So we are plugging f into g. All right, so again, I'm going to do this on a separate sheet of paper because it takes some room. Okay, so I've already got all our necessary information written down. So again, we're trying to form g of f of x, and we will be plugging f into g. Okay, so the first thing I'm going to do is write down the outside function. The outside function is 2 over x, and we are plugging in f of x, the inside function. Okay, so remember, we usually plug in a number to a function. Okay, so everywhere we see x, we replace it with that number. But now we're plugging a function into a function, so everywhere we see x, we're going to replace it with the appropriate function. Okay, so all we do here, okay, is when we look at this, okay, here's my outside function. Everywhere I see an x, circle it. We're going to replace it with f of x. Okay, f of x is 3 over x minus 1. Okay, all right, so here we go. Okay, this is going to be 2 over 3 over x minus 1. Okay, so we've just set this thing up, so it is time to check for our first bad spot. Okay, so here we go. Okay, this is initial setup. Okay, so our first bad spot, usually you can just eyeball it. Okay, you've got a fraction within a fraction. Okay, so the top is 2, the bottom is 3 over x minus 1. Okay, if you concentrate on this bottom fraction, the 3 over x minus 1, you clearly cannot plug in 1. Okay, because then you would have 1 minus 1, you would have 0 in the denominator, and that would cause division by 0. Okay, so we're going to say x cannot be 1. Okay, we have to do that because the simplification process is going to cover up the fact that 1 is a bad spot. Okay, all right, now we can proceed to simplify this. This is a complex fraction. It's a fraction inside of a fraction, so we need to simplify it so we do not have a complex fraction. Okay, remember what I told you to do. We're going to work with the numerator separately and the denominator separately. Okay, the numerator is 2. Make it a fraction. This is going to be 2 over 1. The bottom is the fraction 3 over x minus 1. Okay, now when you look at this, ask yourself, what is going on? Okay, overall. Okay, the numerator is 1 fraction. The denominator is also 1 fraction. Okay, everything is combined into 1 fraction. You clearly see 2 over 1, 1 fraction. And then you see 1 fraction in the bottom, 3 over x minus 1. Okay, there is nothing to add or subtract. You're not adding or subtracting fractions. If you go back to the previous example, we had to subtract fractions first. I'm right here. Okay, we had to subtract fractions. We had 2 separate fractions that we were subtracting. We had to combine them into 1 before we could proceed. Okay, that's not what we have here. Okay, both the numerator and the denominator are already combined into 1 fraction. Okay, so at this point, we just simply have 1 fraction divided by another. We can jump straight to the division process. Okay, so we're dividing 2 fractions. How do we do that? We leave the top one alone. We change division and multiplication. We flip the bottom fraction. So it's going to go from 3 over x minus 1 to x minus 1 over 3. Okay, now we are multiplying the fractions. Okay, so we multiply across the top. It's going to be 2 times the entire quantity x minus 1. So you need parentheses there. Okay, and then across the bottom, 1 times 3. Okay, so this whole thing, it's up to you. You don't have to distribute the 2 through. You can if you want. The bottom is going to be 3. So you can say it looks like this, or you can distribute the 2 and make it 2x minus 2 over 3. Okay, either one is correct for g of f of x. Okay, so this is your simplified composite function. Okay, so let me see here. Let me go ahead and box this for you. Okay, like I said, either version is correct. Okay, you are done because we have just one fraction. There is no complex fraction. You don't have a fraction within a fraction. Okay, at this point, we need to state the domain of g of f. Okay, so after simplification, so we need to find another bad spot. Okay, so we need to look at our simplified product. So we're looking after simplification here. Okay, so I'm going to go ahead and take the bottom and set it equal to 0. Okay, this doesn't make any sense. Okay, if you're solving 3 equals 0, okay, those are just two numbers. 3 is never equal to 0. Okay, there's no variable involved, so there isn't another bad spot. Okay, so I'm going to go ahead and say no additional bad spot. Okay, so the only bad spot here is going to be 1. Okay, we learned at initial setup that you couldn't plug in 1 to the function. Okay, again, if you look at the simplified version, it totally looks like you can plug in 1. I can do 2 times 1 minus 2 over 3 and get 0. Okay, but you know, plugging in 1 is not allowed. We know that from initial setup. Okay, so I'll go ahead and write down the domain here. The domain is going to be all real numbers except x equals 1. Okay, so we know if we draw this on a number line, you know, we're going to put our bad spot of 1 on here. Okay, we're going to exclude it with an open circle, but everything else is good. Okay, so to write this in interval notation, this is going to be negative infinity. We get stopped at 1, throw it out with a parentheses, pick up on the other side of 1, exclude it with a parentheses, go off to infinity. Okay, so here is the domain of g of f. And remember what this means. You can plug anything you want into this new function that we created except for x equals 1. You can't plug that in. That's not allowed. Even though it looks like you can plug it in, you actually can't.